Understand the relationship between reaction mechanisms and rate laws. A reaction mechanism is a sequence of individual, elementary steps that describes how reactants are converted into products. The rate-determining step, RDS, is the slowest elementary step in this sequence. It acts as the kinetic bottleneck, meaning the rate law of this step dictates the rate law of the entire overall reaction. Determine the rate law for an elementary step. For any elementary step, the rate law is determined directly by its molecularity. The coefficients of the reactant species in the balanced elementary equation are used as their reaction orders in the rate law. Analyze mechanism 1. Identify the rate-determining step. Step 1 is marked as the slow step. X2 gives 2x, making it the RDS. Write its rate law. Since it is a unimolecular step involving only one molecule of reactant X2, its rate law is written as rate equals K, X2. This matches the experimentally determined rate law of the overall reaction. Verify stoichiometry. To be valid, the sum of the elementary steps must equal the overall reaction. X2 gives cancel 2x cancel x plus y2 gives cancel xy, 2 cancel x plus cancel xy, 2 gives x2 y2 adding these steps together and canceling the intermediates, 2x atoms and 1 xy2 molecule. Yields. X2 plus Y2 gives X2 Y2. This matches the overall balanced equation. Thus, mechanism 1 is consistent. Analyze mechanism 2. Identify the rate-determining step. Step 1 is also marked as the slow step. X2 gives 2x, making it the RDS. Write its rate law. Its rate law is determined solely by this first step. Rate equals K, X2. This also matches the experimentally determined rate law of the overall reaction. Verify stoichiometry. Add the elementary steps together. X2 gives cancel 2x cancel x plus y2 gives cancel xy plus cancel y cancel x plus cancel xy gives cancel x2 y cancel x2 y plus cancel y gives x2 y2 adding these steps and canceling all intermediates, 2x atoms, 1 xy molecule, 1 y atom, and 1 x2y molecule. Yields. X2 plus Y2 gives X2 Y2. This matches the overall balanced equation. Thus, mechanism 2 is also consistent. Conclude. Since both mechanism 1 and mechanism 2 yield the correct overall stoichiometric equation and share a slow rate determining first step that produces the rate law rate equals K, X2, both proposed mechanisms are consistent, which matches option C. The correct answer is option C. Both mechanism 1 and mechanism 2 are consistent with the rate law.